Hello and welcome. Today we are exploring the structured methodologies used to test artificial intelligence systems during an audit. We will break down the entire lifecycle into 5 core phases, which include definition, development, testing, deployment, and operations, followed by a special look at financial models. Understanding this lifecycle is incredibly practical for your daily professional life. For example, if your human resources department wants to buy a new automated resume screening tool, you will know exactly how to verify if the vendor actually tested for bias, if the data is secure, and if there is a safe way to pull the plug if things go wrong. You can use this exact framework to confidently greenlight or reject any intelligent software proposed for your enterprise. The first major phase of our methodology is the definition stage. This area validates that the enterprise fully understands exactly what the application is being used for before any building begins. Think of this like reviewing the blueprints before constructing a bridge. You would never pour concrete without confirming the weight capacity, the destination, and the environmental risks. In this area, you must evaluate the business case requirements. You need to identify clearly defined goals and the exact problem the technology is meant to solve. You must confirm the expected business value, review how it impacts current processes, and see if a change management plan is ready to help employees adapt. Furthermore, you must verify the specific use cases, the intended data sources, and the proposed timeline. Beyond the business case, you must scrutinize project dependencies. This means identifying potential risks and ensuring the system will be transparent to both internal employees and external consumers. You also need to confirm that ethical considerations are woven into the initial design and that a realistic adoption plan exists. Next, we move into the development area. This phase investigates how the solution is actually built, focusing heavily on the information used to teach the system. Different algorithms require vastly different types and volumes of information. For instance, a system designed to recognize medical anomalies needs thousands of varied medical scans. Your primary focus here is data management and sampling. You must verify data governance, which involves checking if the organization has strict rules for information access and retention, and proving that staff actually obey those rules. Then you evaluate full testing and population sampling to ensure the training material perfectly represents all demographic groups, subgroups, and extreme edge cases. Let us clarify a concept called sampling methodology. Sampling is simply selecting a smaller representative group from a massive pool of information. You can do this randomly, manually, or by using stratified sampling. Stratified sampling is a technical term that means dividing items into distinct categories before picking. Imagine you are inspecting a massive shipment of fruit. Instead of just grabbing the top 10 apples, you deliberately take 2 apples, 2 oranges, 2 bananas, and so on, to ensure your sample reflects the entire shipment. You also need to check for dirty data. Dirty data is industry jargon for information polluted with errors, duplicates, or strange special characters. Just like a chef must wash mud off vegetables before cooking, data scientists must manipulate and clean dirty data before feeding it to the model. Finally, in the development phase, you must evaluate data integration. You verify the controls used to collect and move information. You must ask if application programming interfaces are locked behind passwords or dangerously open to the public. You also confirm data integrity by taking a sample from the original source and comparing it to the moved data to ensure nothing was altered during transit. The third phase is the testing area. This is where you prove that the processes used to train and validate the system are scientifically sound. Think of this as putting a new aeroplane design through thousands of simulated flights before installing the passenger seats. You must evaluate model development and tuning. This involves analyzing the system for algorithmic bias and measuring fairness. You evaluate transparency and explainability by reviewing how the system makes decisions. You check if stakeholders are properly informed, if users have a way to opt out, and if fundamental user rights are respected. Then you assess model performance. You ask how often the system actually makes the right prediction or meets the required service level agreements. The testing team must show you their performance measurements. Let us translate some highly technical grading metrics you will encounter here, specifically the confusion matrix. recall, and the F1 score. A confusion matrix is simply a scorecard grid that tallies exactly what the system guessed correctly and what it guessed incorrectly. Recall is a metric showing how many of the truly relevant items the system successfully found. The F1 score is a single combined grade that balances accuracy and completeness. Imagine a factory worker inspecting a conveyor belt for cracked glassware. The confusion matrix is their clipboard tally sheet. Recall is the percentage of actual cracked glasses they successfully caught. The F1 score is their overall performance review, penalizing them if they missed broken glass or if they mistakenly threw away perfectly good glass. Next, you evaluate interface integration. You review user acceptance testing results, gather user feedback, and rely on your own experience to confirm the tool actually works in practice. Crucially, you test for rigorous compliance. This means verifying adherence to internal policies and external standards like ISO 27001. You must ensure the system obeys jurisdictional laws such as the General Data Protection Regulation, the California Privacy Rights Act, and the EU AI Act. You also review ethical considerations, ensuring accountability, and confirm that proper regulatory notifications are ready for when the system goes live. Our fourth phase is deployment. This area evaluates how safely the technology is released into the enterprise or to the public. You must review the release management plan, paying extremely close attention to the rollback plan. A rollback plan is an emergency reset button. If a newly launched automated payroll system starts paying everyone double on day one, you need a pre-approved method to instantly shut it down and revert to the old software. During deployment, you also evaluate the rollout process itself. You confirm that internal staff and public users have received proper training and awareness materials. Lastly, you verify that any mandated notifications to industry regulators have been officially submitted. The fifth phase is operations. After the launch celebration ends, you must evaluate the ongoing day-to-day support. Implementing an intelligent agent is like buying a high-performance commercial truck. You cannot just drive it forever without regular maintenance and safety diagnostics. You must verify that robust support exists for both internal employees and external customers. You evaluate reporting measures, meaning you prove that the model stays accurate over months and years, even as entirely new data is introduced. Furthermore, you investigate how the operations and development teams work together to continually improve the system and how they handle routine updates and security patches. Finally, we must address the specific testing considerations for financial models. When an intelligent system touches the financial sector, your audit requires an extra layer of scrutiny. First, you must conduct journal entry testing. This means you meticulously validate any automated data entries generated by the artificial intelligence to ensure they are mathematically perfect. You must also secure and analyze specific logging records. These include the initial model training logs, the real-time financial decision logs, and the comprehensive audit trails, paying special attention to error logs. Successfully auditing this sector requires a mindset known as professional skepticism. Professional skepticism means you never take anything at face value. Think of a seasoned detective listening to an incredibly convincing alibi. They will still demand to see the security camera footage. As an auditor, you must apply critical thinking to the development processes. You aggressively question how the data was collected. You actively probe for misstatements caused by simple errors, intentional manipulation, or outright fraud. And you must always independently validate the results of any algorithmic testing, especially bias checks, to guarantee the integrity of the system. Let us recap our session. To comprehensively audit these systems, you must assess 5 core lifecycle phases. You validate the business purpose during definition. You secure and clean the training materials during development. You measure fairness, performance, and compliance during testing. You establish rollback plans and training during deployment. You monitor ongoing accuracy and updates during operations. And finally, you apply intense professional skepticism and strict journal testing when dealing with any financial models. Excellent work navigating this complex methodology. All the crucial vocabulary, metrics, and concepts from this session are covered in the multiple choice questions on RooCloud.com. I strongly encourage you to log on and solve the chapter-wise questions to reinforce these testing phases in your memory before we move forward. Thank you for watching, and I will see you in the next episode.